Part 4, last lesson for today, multiplying special cases. Now, I want to start with the layout. The reason these are called special cases is what if you have the same terms but different signs? Okay, now, if I do the area model, okay, you have A plus B and you have A minus B, okay? You would get A times A is A squared, B times A is BA, A times negative B is negative BA, and B times negative B is negative B squared. All right, if I write this all together, my answer would be A squared, sorry, let me move this a little higher, A squared plus BA minus BA minus B squared. Now, if you notice, these two are just A squared and B squared, but these two, they're the same pattern, BA, B times A, B times A, but one is positive, one is negative. If you combine those, what would happen? They're opposites. They would cancel out. So what are you left with? A squared minus B squared. And guys, that's what happens. Every time you multiply this special case, you have the same terms but opposite signs in the middle. You end up with just the first term squared minus the second term squared. That's it. That's the answer. Now, in this case, they're the same signs. So if we do the same thing, area model, okay, AB, AB, you're going to see something very similar, right? A times A is A squared. A times B is AB or BA. Actually, the order doesn't matter at this point. A times B is AB, and B times B is B squared. Now, when you put these together, instead of canceling out, how many ABs do we have? How many of these terms do you have? 2 of them. So when you combine your like terms, instead of canceling out, you have double A and B in the middle. They don't cancel out because you have to do AB plus AB. And guess what that is? AB plus AB is 2AB. Remember, this is not multiplying anymore. You multiply it first, but once you have your individual answers, you are adding up your answers. You're adding them up. And you can only add up your like terms. Now, what if they're both negative? What if it looks like this? Very simple. So, guys, what's the difference? If you look at it, the only difference is the middle number. The number in the middle is negative 2AB. Wait, what about this one? Well, negative B times negative B is positive B squared. So, you basically get the same thing, except the middle sign is negative. So these are why they're special cases, because they always kind of follow this pattern. So here's a couple examples to show you how it works. Okay, now this has a name. Okay, there's a perfect square. There's a perfect square. What this is 2x plus 6 times 2x plus 6. That's a perfect square. So when you multiply it, it's going to look like this one. It's going to look like this one. Okay, you can do your area model, so feel free to do your area model, but I've learned what this does. 2x times 2x is 4x squared. 2x times 6, 12x. 6 times 2, 12x. 6 times 6, 36. That's what would be in your area model. Now, what do you do with the 2 terms in the middle of your area model? What do you do with those? You add them up. So your answer for this is 4x squared plus 24x plus 36. Now take a look. What is 2x squared? 2x times 2x? 4x squared. What is 6 times 6? 36. What is 2x times 6? 12x. But double it, 24x. It just always follows this pattern, okay? Now, this one, however, is not a perfect square They call it a difference of squares. Now you can do the area model. It'll look like this. So what's going to happen? Those two will cancel out. And you're going to be left with what numbers? Just a squared and b squared. So if you recognize that, and you see, wait, they're the same numbers but different signs, then the only thing that's going to happen is you're going to get 3x times 3x is 9x squared. Negative 5 times positive 5 is negative 25, and there's no terms in the middle because they would cancel out, and I'm done. So the idea of these special cases is that you can save time if you recognize it and just follow the way these expressions are written. Okay? Now the last thing I'm going to show you is a word problem that uses one of these cases. So let's say there's a square garden, okay? And the garden is, around the garden there is 1 foot square bricks kind of acting as a barrier. So if you draw that, right, you'd have a garden, right? But then you have these bricks all around it that are 1 foot long, all around it, okay? So you have 1 foot bricks on all sides, 1 foot, 1 foot, 1 foot, 1 foot, right? 1 foot. So it's like almost like a fence, right? It's like blocking, keeping the garden blocked off, right? So if they want an expression for area, but they don't tell me how big this is, I'm just going to put x here. And because it's a square, I know this is also x, okay? So the area inside is x squared. But if I'm going to do the area of the whole thing, including the bricks, then you have to recognize this. My length is 1, x, and 1. That's how long that side is. If you add that up, that would be x plus 2. And here, if I take the entire length of this, or width, I kind of forgot what I said already, you have 1, x, and 1. And guess what that is? X plus 2. So if you're going to find the area of this, you are taking the length times the width. So you're doing x plus 2 squared. That's how you're going to find the area. So that looks like this. The same two terms giving you an answer like this. So if I keep that pattern in mind, right? If I keep that pattern in mind, that means that the first term in my answer is going to be x squared. The last term is going to be 2 times 2 is 4. Now what's going to be in the middle? 2 times x times 2. So what is x times 2? 2x, but double it, 4x. So your answer will look like this. And if you don't believe me, you can make the area model, okay? You can make your area model. You can do x and 2. You can do x and 2. And you'll see you'll get x squared, 2x, 2x, and 4. You combine your like terms, you get that, okay? But that's it, guys. That's how you do it.